everybody, and thank you for the opportunity to present our study. I'm Suikkanen from National Institute for Health and Welfare, Finland, and University of Helsinki. I'm a medical doctor and doing my PhD. And today I'm presenting our results of pubertal timing of children born preterm. Sorry, how do I... Yes, now it went too much. Sorry.
Do you want to go back a slide?
Yes, please.
Can we go back a slide, please?
Well, while he's working on with that, I hope. Okay. Yes. No, it doesn't show my first slide. Well, okay. Well, first I was about to tell you about the aims for this study. So the aims were to study the timing of puberty and to especially timing of pubertal growth of children born preterm and the timing of peak height velocity. We also wanted to look the effect of small for gestational age birth weight and other perinatal and postnatal factors. We also evaluated the timing of menarche and voice break. And the reason for this study were because it has been well presented that adults born preterm, they have higher burden of cardiometabolic risk factors. So, and this has been mostly shown with adults born very low birth weight or very preterm, but we also have, some studies have also shown similar results in adults born closer to term. And in term-born adults, it has been shown that in them, the earlier pubertal timing predicts higher cardiometabolic risk. So we thought that maybe the higher burden of cardiometabolic risk factors of those born preterm goes partly through earlier pubertal timing. And we have previously presented in a very low birth weight cohort that they have earlier timing of pubertal growth. So now we wanted to study this in a cohort including children born across gestational ages. And this cohort, that's called ESTER, we have about 750 participating young adults in this. They all have taken part to a clinical examination at around 23 years of age. And we collected the perinatal and postnatal data from the hospital records. In Finland, almost all children take part to clinical examinations in child welfare clinics and school healthcare. So for those reasons, we were also able to collect the growth data for about 600 of these participants. And by that, I mean that we actually have over 9 height measurements for these 600 participants at above 5 years of age. We excluded those with severe disabilities, and then we ended up with a study population of about 100 of those who were born below 34 gestational weeks, and we call them early preterm group. And then we have about 200 of those who were born late preterm, between 34 and 37 gestational weeks, and around 280 who were born at term. Now I'm using a little bit of time of explaining the method we used at evaluating the timing of peak height velocity. So the SITAR model, that's a statistical model that creates a mean spline curve for a group we are interested in, and it explains the individual variance with 3 parameters. A parameter can transfer the height curve on a y-axis, and from that we can calculate the final height of the participants. And the B parameter, that transfers the curve on an x-axis, and from that we can calculate the age at peak height velocity. And then the C parameter, that's stretching and compressing the x-axis. So from that we can calculate the peak height velocity. That figure over there, that's just one example from our data. So the red dots, they are the real measured heights, and the black curve, that's the individual sitar curve that the model creates, and then the blue curve there, that's the curve for that gestational age group. And what we did, that we studied the difference of the early preterm, late preterm, and term groups inside this model. And even what can be seen from this model is that the sitar seems to be fitting the real measured heights really well, and it actually explained over 90% of the individual variance of our data, and that's similar to other studies made with the same model as well. Now to the real results. So as you can see even from these figures, is that it almost looks like that there is only one curve for men and one for women, because all gestational age groups seem to be growing so similarly during the puberty. So the left figure there, that's showing the mean sitar curves for each gestational age groups, and the vertical line, that's telling the age of the peak height velocity. And then on the right side, that's the velocity curve for all three gestational age groups, and again they go so similarly that it almost looks like there is only one curve. We also performed these same models with adjusting variables with several perinatal and postnatal factors, also socioeconomic status and parental heights, and still they look quite same, no any significant differences. We also looked the group of those born small for gestational age and preterm, and even them they didn't show any difference to the term controls. And here you'll see the figures of the menarche and voice break, and those were we asked from our participants in young adulthood, and there is no difference at menarche age or voice breaking in any of the in the gestational age groups either. And more like as a background information is that in this cohort the final height is same in all gestational age groups. So to conclude, we didn't find any differences of early preterm, late preterm, and term groups, pubertal growth, and also the timing of menarche and voice break was similar in all three gestational age groups. So when we are looking at the data who includes participants born across gestational ages, we didn't find differences at pubertal timing. And these results do not support the idea that preterm birth, that the higher risk of those born, higher cardiometabolic risk of those born preterm would have something to do with timing of puberty. Thank you.